Hey guys, today's day 12 of learning OpenGL to make my game engine, and today I'm learning about vectors and the cross product. Previously, I learned about the dot product, and all that showed was how to project one vector, assuming the L vector, onto the O vector. So basically you could imagine it as a line being drawn down, like a triangle. Based on the triangle, we could use the Pythagorean theorem to calculate this projection. This projection can be calculated using theta, and you end up using cosine. So cosine theta. That's how you end up getting this angle right here. However, now we want to calculate something called an orthogonal angle or vector relative to both these vectors. So orthogonal basically means involving right angles. So we want a right angle relative to both of these vectors. So that would end up looking almost like a 3D projection. So imagine the vector going upwards, and the right angle is going to be here, and it's also going to be here. So it's almost like a 3D version. That's basically what we're calculating. So instead of using cosine theta, because we're not trying to calculate the projection, we're trying to calculate an orthogonal angle or a vector relative to these two vectors. So instead of using cosine theta, we're going to be using sine theta. Sine theta allows us to calculate this angle right here. It's almost like involving like a whole circle. That's why we use sine and cosine. So instead of projecting it right here, we could just think of the value projecting all the way back onto here, like this vector. So instead of drawing it that high, you draw it a little smaller so it makes it resemble and make more sense. So basically what this allows us to do is allow for more of a 3D projection and allow there to almost, like I said, give a 3D aspect to it. Instead of working with 2 axes, we can work with 3 now relative to those angles and place the object here. So like just say imagine you had like a square object, for instance, right here. Now you have its sense of direction relative to the middle point. So now you could calculate if it's going up or down. And right here would be the y-axis, this would be the x-axis, and this would be the z-axis because it's pointing backwards, or you can end up pointing it forwards, however you want to calculate that. But that's basically what it gives us. It gives us a sense of direction and allows us to project 3D coordinates. But yeah, that's day 12.